Hello everyone, and welcome to our team's demonstration video for the Fall 2016 Computer Science 461 final project, which is computer security at the University of Tennessee, Knoxville. And this project entails creating a VPN or virtual private network. We accomplish this by using Ubuntu's built-in TUN device, which simulates a network layer device and operates with layer 3 packets, such as IP packets. Both TUN and TAP are common network interfaces for creating a VPN on top of. And essentially it works by a user space program is usually attached to the TUN or TAP virtual network interface, and packets sent by the operating system via the TUN-TAP network interface are delivered to the user space program, and on the other hand, packets sent by the program in user space via the TUN-TAP network are injected into the operating system's network stack. To the operating system, it appears that the packets come from an external source, though the virtual network interface is being used. And our VPN is running over UDP as opposed to TCP. And so now that we have a network tunnel established, if we can secure it, we will essentially get a VPN. And this was the next step of our process. To secure the tunnel, we need to meet two criteria of security. We need to meet confidentiality and integrity. So confidentiality ensures that no one else can read our messages being sent, while integrity ensures the reliability that all of the data that we send makes it to the other side of the tunnel. And confidentiality is achieved using encryption, while data integrity is ensured by a special message authentication code, or MAC. And our encryption method implements AES encryption algorithm with cipher block chaining. And now it is important to understand that in a real-world setting, you should not attempt to implement your own encryption unless you are an absolute expert and know what you are doing. Yet for demonstration and learning purposes, we have chosen to implement these algorithms manually. And furthermore, we have manually implemented the HMAC SHA-256 algorithm and agreement method. And an alternative method would be to use the OpenSSL libraries function to do this heavy lifting for you. And one caveat of our system is both encryption and message authentication operate off of a static pre-shared key on both sides. That is, they are not dynamically exchanged at runtime. And now we will perform a demonstration of our VPN network tunnel by using two VMs. Seed 1 is going to be our host or server side, and Seed 2 is going to be our client side. So I will invoke our Python script, simpleton.python, to use usage. Oops, apparently I can't spell. And it will show us our usage, and we run it by, we have to run sudo to connect to the TUN device. Sudo python server, and give it a port number. We're just going to use 55555 because that's a typical unused port number. And we'll run it on the server side. It'll ask for password because running sudo. And now it tells us that our interface is configured and we can use it. While on our client side, we will do a similar process. Python, except we tell it that it's the client side and give it the source IP number. And port number. Now this will connect to the port that we've established in our server side. So, and it prompts us for a message to send. Hello, world. Although this is not the world, this is server. And you get the idea. So our messages are sent in encryption. They're encrypted before they're sent, and they're decrypted on both sides successfully. It checks the HMAC, as we mentioned earlier, to make sure messages are authentic, and security is ensured. And when we want to exit the conversation, we simply type exit, and it will terminate the connection. Thank you for watching.